The topic today is area of part of a circle, and we have this question to illustrate. The figure below shows two intersecting circles with centers P and Q and radius 5 centimeters and 6 centimeters respectively. AB is a common chord of length 8 centimeters. So the diagram is as shown. Calculate the length of PQ for part A, and then part B, the size of angle APB, Roman 1, Roman 2, the size of angle AQB, and then finally the area of the shaded region. So to begin with the first part, the length of PQ, so we're going to get PQ, and in order to get PQ, we are going to extract triangle PAQ, this one right here. So we have it right here. So here is P, here is Q, here is A. And then we have this height. So we were told that chord AB is 8 centimeters, and from A up to this point is half AB. So here should be 4 centimeters. AQ is 6 centimeters. PA is 5 centimeters. So we are interested in length PQ, so we are going to divide PQ as follows. So from here up to here, let's have it as Y, and then from this point to this end, let's have it as X. So that PQ will be given as X plus Y. But by Pythagoras theorem, X should be so that is the square root of hypotenuse squared, which is 36, minus height squared, and that is 16. So we are going to get the square root of 20, which is 2 root 5. Also, y, we are going to apply Pythagoras theorem to get it. So we have the square root of hypotenuse squared, which is 5, so that is 25, minus the height squared, which is 16. So they have a common height. So this should be the square root of 9, and that is 3. So this implies that the length PQ should be X plus Y, and X here is 2 root 5. So we have 2 root 5 plus Y, which is 3, and approximately this is 7.4721. Next, for part B, the size of angle APB. So first of all, we are going to extract this triangle APB as follows. So we have the triangle right here. So here we have P, here we have A, and then B, and then you have P up to that point, which meets AB at 90. So let this angle be theta, which is also the same as this angle here. So the dimensions were given here 5 centimeters, then this is 4 centimeters. Remember, AB is 8, so here is 4, here is 4. So using this diagram, we can get theta. So we are going to apply SOHCAHTOA, of which for this case, theta is related to this side and this side by sine. So that is opposite over hypotenuse, opposite hypotenuse. So we are going to have sine of theta is equal to opposite, which is 4 over the hypotenuse 5. So that theta becomes the sine inverse of 4 over 5, and that is 53.13. But the question requires us to get angle, or rather APB, and angle APB is twice angle theta. So the whole of APB is twice angle theta. So That means APB should be 2 times 53.13, and that is 106.26 degrees. Next, for angle AQB, here we are going to concentrate on this triangle AQB. So let's draw it here. So we have again, here is A, here is still B, and then we have Q. If that is Q, AQ we already know is 6 centimeters. Now we can let this angle be alpha, which is the same as this angle. So here still 4, and here also 4 centimeters. So we are going to have sine, according to SOHCAHTOA, still opposite and hypotenuse. So we are going to have sine of alpha is equal to opposite, which is 4 over the hypotenuse, which is 6. So that alpha is equal to the sine inverse of 4 over 6. And that should be 41.81. But we also know that angle AQB is twice alpha. So we have twice alpha, the whole of this angle. So that means AQB is 2 times 41.81, and that is 83.62 degrees. So lastly, we have C. We have to determine the area of the shaded region. So we are going to get the area of this shaded part. So what we need to realize is that we have two segments at this particular point. In other words, we have a sector AQB, this one here, intersecting with sector PAB. So where they intersect, that is the shaded region. So we are going to break it down as follows. So we have this sector PAB, you can draw it here. So here is P, here is A, and here is B. So we are interested in this first part here. Let's call it segment 1. And then this angle here is 106.26. Here we have 5 centimeters. So the area of that segment will be given by getting the area of the whole of this sector, and then you subtract the area of the triangle. You remain with the shaded part. So we are going to have area of a sector given as theta over 360 pi r squared. So theta over 360 pi r squared, and that is times 22 over 7 times the radius squared. So that is 5 squared, 25, minus the area of the triangle. So we have a half the radius squared, 25, sine 106.26. So this is going to give us 23.1917 minus, so when we work out this, we are going to get 12.00. So we end up with 11.1917. Next, we are going to get the area of the other segment. So this part here, this side. So let's sketch it. So we have the sector. So here is A and here is B. So we shade here. So this is the segment 2. A, Q, and this length here is 6 centimeters. And the angle here we found to be 83.62. So we are going to get the area of segment 2, which again is area of the sector minus area of the triangle. So we have theta over 360, so that is 83.62 over 360 times 22 over 7 times the radius squared, that is 6 squared, we have 36, minus area of the triangle, so we're going to have a half times radius squared, that is 36, times sine of 83.62. So this, from my calculator, I get 26.281, and then this other side I get 17.889. Working out this, my answer is 8.392. So in order to get the area of the shaded part, we are going to combine the two segments, and when you combine, we are going to have something like this. So we are going to combine segment 1 with segment 2 to form the shaded part. So that is obtained by simply having, that is the area of the shaded region, that is going to be area of segment 1 plus area of segment 2, and that is 11.1917 plus 8.392, and that is 19.5837. That is approximately 19.58